Test, test. Hello? Hello? Okay, cool. Alright, cool. Anyways. Alright. So this will be another quick one. I'm just going to record me just taking out the fan and putting a new one in. Nothing crazy. Standard stuff. Working on these units. Just have a boatload of them, so. Get out of the way on this one. Yeah. Let me go over here. There we go. Cool. All right. So yeah, let me know if you have any questions, concerns, or want to see something or try something out, or I'm down for whatever today. I'm just really just working on putting a fan on this, testing it out, putting high beam on it. The new firmware that I've got to update to be the primary one, which has everything connected. High beam, artisan. So I'm trying to just make sure it's stable. And also working on these units to, you know, sell them back. Don't learn a lot from it, but you know, don't make a lot from it, but just good. Just kind of show everyone how easy it is to work on these things. They're not really complicated machines at all. Meaning they're just built really cheaply. Or affordably, I should say. Let's put that in here. There we go. And hey, there we go. These screws out. That looks dark. Boom, boom, boom. Pop this one out. I should hold this in. There we go. It should come out like that. And voila. Let me pull this thing out too. I'll usually just grab it from here and I'll pull it. It's sometimes a little bit tight. You just gotta wiggle it. And then, yeah, heatsink isn't gonna go anywhere. It won't break or anything, so give it a good tug on there. Sometimes I'll take the NTC probe out just to get some more space. Good. And then I'll add the fan here. So this fan just goes right here. Sticker side's blowing into it, so I'll probably put that fan right here, and then that should be enough to cool it off. I always put it all the way on top so it's not touching any of the circuits at the bottom. I also kind of want to test something out, because I think this one turns on. This plug in general, I think that turns on like when the unit starts to roast. So I'm gonna double check that today before putting it back together. So I'm gonna put it in just like this. This up, move this way. There we go. Going just like that. So we'll take some wires out of the way so you can at least see it a little bit better. All right, so this one is the power supply connection from power supply to the main board. And then this one I think is exhaust and then drum. No, wait, this is exhaust. This is the drum one. So maybe I'll take all these wires out. So that is drum, this is exhaust. Although, it's kind of surprising that's exhaust considering how much thicker this wire is. Good. And you only have to do this type. I only recommend like on certain V1s. If you get the one with the fan on the outside, that V1, because there's kind of different variations now. But if you're able to get that one seems to work out a lot better to installing. It's a lot easier to install that fan versus this one, where you actually have to like drill. But you don't necessarily have to do it this way. You can also just, drill holes at the side, and then put a fan, like just stick it on there, screw it on there. Oh. Requested to speak. Okay. If you got a mic, I'll invite you. flex cable. That seems to be working fine. All right, that works. I got goggles this time. I'm being good for now. Although as I wield this around wildly, hey, those wires are gonna get in the way. Let's go tuck those behind here. And I'm just gonna cut this thing right here. It's kind of annoying. To one side. Blow this out. Okay, blow that one side out. Go find my 12mm screws. There it is. So this aluminum heatsink is super soft, so you can easily just like, don't even have to use a tap anymore. I used to use a tap, now I just screw it in with like the hex. Hopefully not that one. That's not the size. I'll just thread it in like that. I used to use a tap. It's kind of a waste of time because it's so soft. You can just literally use a screw to kind of tap that in. You move some things around. And I'll do this other side. I sent it off. Well, it should be sent off. Hopefully it gets to you on time. You don't have to do any of this stuff either, so that's a plus. So I'm just gonna flip that over right here. That one sold, but I got other ones. I've got plenty of other ones that are dented. Not a lot, but there's like, that was just a big dent on that one. I got other ones that have, smaller dents you can just cover up with a sticker. I just wanted to sell that one because I had a really big dent. It worked perfectly fine. I just had a really big dent on it. And the guy lived close by to me, so in case it does any issues, I can easily service it. Yeah, if I sell one to anyone like that lives close to my area, I'll definitely service it for free. Like if you could drop it at my house, I'll be like, yeah, sure, I'll take a peek at it. All right, so this one. This one is the power supply. If it's thin like that and it's to the right, that's usually the NTC probe. And it'll even say NTC on it. And of course, if I forget which placement it is, I'll just look up Skywiki. I'm trying to keep this thing up. I'm trying to keep this website up to date. Sheesh. It's the hardware main board. So yeah, drum, exhaust fan. So power supply, drum, and exhaust fan seems to be there, the way they're keeping the boards. So drum. And last but not least, the exhaust fan. But let me put this back in first. Actually, I was going to double check this fan. So let me put this back in. I want to see when this turns on. We're going to plug this back in. I'll leave that exhaust fan off. It'll work fine without it. We'll go back to here. Let's see when the exhaust fan turns on. Let me plug this unit into here. Cool. All right. Well, that was nice of them. Finally figured out what that's for. All right. So if we look at it here, and this is for anyone who decides to put a fan in, if you hook it up to this port, if you have this connector, as soon as you turn it on to heat, and I'll do it up here. So I want to preheat. Turns right on. So I think that's just straight up 24 volts going into that fan to turn it on, and now you have a easy way to power or supply it. So I guess I need to update that main board picture to add this one. So it looks like from here it is, yeah, same kind of wire setup they have on the other port. So if you look at this little retaining, I should turn it off. I already shocked myself twice, so lesson learned. Okay, so if we look at it here, take this out, and yeah, so it would be, so, you know, pretty much positive on this side or red, and then ground on the right when you're looking at this clip right here. So voltage on the left. And that should be 24 volt. I'm also going to check this one here. Let's see how many volts come out of here. I don't know why I decided to start doing this now. I should have done this a long time ago, but what happens when you're lazy? So real quick, I'm just going to check the polarity and see what it's at. Another polarity. I'm going to check what the voltage is. If that's a 5 volt, I have plans. I have plans if it's a 5 volt right here. This is more than likely 24 volt. But I want to try something with it, but let me see how many volts it is. Gotta find another banana plug. I think I put it in here. There it is. All right, where's all my stuff? All right, so let's go see how many volts come out of there. And then I'll tell you guys what I'm gonna plan on doing next with this upcoming batch of motors coming up. Basically, working on an upgrade path for all the motors to still work with the original controller board. I want to try something out. I just got to make sure it works. And I can make it all self-contained rather than having to put another power supply in there. But I'm looking at a few different avenues. Let's plug this back in. Shaky hands. Oh, yes. All right, so that's 5 volts. It says 4.9, but it's pretty much 5. All right. So, all right, here's the plan going on. Since this is 5 volts, this little thing right here comes out 5 volts. I was planning on just hooking up, powering an ESP32 directly onto there, a separate one, and then this ESP32, you know, when turned on, would just PWM the V2 motor that you could buy independently, and then once that starts, like anytime that would be on, it would just turn the motor. Or it would, sorry, let me just rephrase that again. So I was thinking of just putting the ESP32 connected to here, and then power the motor through the motor slot port. Like it still have the 24 volt power going to it, but then the ESP32 is just basically acting as a PMW signal generator. So so it's on the whole time, and then once you turn on the 24 volt onto the board, it'll just send 24 volts to the motor. So basically, it would turn it on, but the ESP32 would be sending the pulse, the pulses to signify when to do like 60 RPM constantly or 55 RPM constantly. So then the motor would spin, and it should work like it would if you just use the regular controller, which is the biggest thing I want to work on. But at the same token, you still have it connected to an ESP32, which are usually like $5 to purchase. So you can have one of those inside and have somewhat of some type of control with it, whether it be through Wi-Fi or Bluetooth or whatever, and try to integrate that with Artisan so you could have some control of it. But I just have to look more into that. There's another way you could do like ESP now, where it's like ESP, 2 different ESPs can connect to each other. One can control one ESP32. So like the main ESP32 with high beam would control the ESP32 that connects to the drum motor. So you could send data to it to increase the PWM signal to like whatever 100% would be, or whatever 50% would be, or even have that ESP32 connected to that brushless motor to send the RPM. So you could see here how many RPMs that it's at, and cool stuff like that. But the only issue was I didn't know where I could find a 5 volt to hook up a ESP32, because there's a port on, not a port, but like a part of the ESP32 where you can hook it up, and it'll have 5 volts to it, and it'll power the whole thing. Not to say that it reads like 5 volt, like I think signal line, like signals, it doesn't read like 5 volt, but it does like 3.3 volts with that. But there's a section on the ESP32 where it does convert 5 volt into 3.3 to power the ESP32. So that was kind of like the thing. So now That's one way. I'm gonna try, when I get the motors in, I'm gonna try hooking it up like that. I gotta figure out the code for it. It should be really simple code. Like it's literally just sending it up, sending it the signal that it's running, at 50%, 50% PWM or whatever. So I'll send that, and then the motor will just run like that constantly, or I could change it to where it'll run to, I think there's a way you could calculate it where it'll take RPM and then calculate it to where it'll send the PWM. It'll increase it if there's like a decrease, because when you put a load into the beans, into the motor, the torque increases, and of course the jump speed slows down. So one thing you could do is have a calculation in there where if you want to keep it at like 55 RPM, you can use there's a signal line on the on those brushless motors that can calculate the speed of the motor. So you could hard code like 55 RPM, and it'll keep at that speed. So that's one of the cool advantages of getting the motor, because the ones that they send in the V2, they take out that signal wire for some reason, or they don't use it at least. But for us, we can hook it up to an ESP32 and calculate RPM. So that will be the next project. Will be to hook up one in here and see how that goes. I'll find it pretty interesting. Hopefully we can get V1s where you just turn it on and it'll be running at like 55 RPM instead of the 60 RPM or 50 RPM. We could have it run at 50 RPM. And then with that though, when you upgrade to like the brushless motor, you'll just need a fan right here. You just need a fan on top, blowing directly onto the motor to cool it down. But that'll be a few days till I figure all that out, or a few weeks. But yeah, that's kind of the next plan, is to get a V2 motor in here without having to pay V2 prices. If all said and done, if I could do it the way I'm thinking, it should be $30, no, $25 for the motor, $5 for the ESP32, for the extra ESP32. I mean, technically you can have the ESP32 working out and then just have a wire, like use the same ESP32 you would use, but I just want to stick with keeping the controller board working how it would factory. So people with the factory boards who still like using the factory boards are able to roast with it. But cool. We figured that out together today. So two things we figured out is that this little port runs 24 volts, so you could run a fan over here. Next thing we figured out is that there's 5 volts coming out of here, which I need to unplug because I keep touching it like a retard. There we go. All right, like an idiot, I mean. And then 5 volt come out of here. So only issue now is now you have to have some soldering skills. It's always a give and take, but I'll take that. Because then the other way, if you wanted to do 5 volts to the ESP32, is you have to get it to decent like 3.3 volts, or you have to get like a power supply. So another power supply on top of this one. Oh, fun fact. Okay. So if you're really getting into modding this stupid thing, and you're really trying to hot rod it, I think at most, I think these power supplies, they, I want to say the S30, the 30 stands for, because they call it a HYS S30 24AZ is the model number. And model numbers usually indicate, especially with the numbers, like maybe the voltage. So voltage would be like 24. And then 30, I'm assuming, is watts. So altogether, you can only have like 1.25 amps, right? So if you only have 1.25 amps, you're kind of limited if you want to add bigger fans to cool off the beans before the whole power supply blows itself up because it's just using it too much. I did find out that These will fit pretty much into there. I'm gonna grab a case. Yeah, so this one, if you do need a replacement and for some reason you can't get one, should fit right into there. All right. And what is this? This is a another power supply, just bigger, has more amps. So basically it is a 24 volt, I think this has 3 amps. I'd have to do math to calculate how many watt, like the pure wattage of it, but basically it's a DC 24 volt, and then 3 stands for the 3 amps that it has. So if you want to add more crazy fan solutions to cool your beans off, or if you don't want to use an external cooler, you could do that without having to turn everything off on the machine. Also, you could experiment with more things. I mean, these work fine. They're bulletproof. You don't really need to change it unless you're if you decide you wanted to do some mods, or if you want to find something a little bit better, then you could probably use one of these power supplies. These are basically what the Kaleidos use. This is basically the type of power supply they use. Not the same brand. They use some brand WX whatever, but they're all copies of some. So, except the one, if you were to buy from Kaleidos, like a espresso outlet, they charge you like $80 for this when you could buy it for about 20. And it does the same thing. Input in, outputs 24 volt, power supply. Basic DC, AC to DC power supply. So, in case you want to add like big cooling fans, or if you want to do some more projects, like I was going to think about adding one of these little turbine brushless. It's basically one of these motors that you'd find in here. So, yeah. Except they output a lot of air. I don't know how much CFM it is, but it feels like a lot. So this is like 10 bucks. I think 11 bucks. I'm gonna try to like 3D print a just have one of these, 3D print like a little bit of a split divided thing, and then have it see how fast it can cool the beans with just using this. I think it's pretty quick. We'll see. Another project for another day. I just realized I have to face it towards this way to blow. Oh well, we'll figure it out. Yes, basically it looks like, yeah, I think this is the same exact fan. You know what? Why don't I just, hold on. Okay, let me be a nerd real quick. I'm going to test out something. So, I have one of these anemometers. One of these anemometers. As I used to pronounce it, I don't know how to say it. I don't know. I got one of these air measure meter things, so I'm gonna give this a shot. 2578. 2578 feet per minute. Okay. Let's write that down. We're gonna do science stuff. I'm gonna write that down somewhere. Hold on. 2578. 2578 feet per minute. Something like that. PM. Min. Sorry. Feet per minute. Whatever. Let's grab one of these fans out. Hook back a controller. So 757 to 8. I'll put it close. I'll put it real close. Give it the best number it has. 11,000. Well, 1,080. 1,082. 62. Actually, why did I do that? I could just kept it in here. So right now, with this setup right now, about, if I'm really, really close, it does about 1,102. Let's go. So 1,102. No, it only does about 900, about 1,000. No, 908. Let's get the average. So around 965, 984. 984. So let's write that down. So 984 feet per minute. Let's do some ghetto testing. All right, let's turn this off. All right, so about the same distance. Let's bring this out a little farther. Go from here to here, and here's just one motor. 2,715. Okay. Sweet. Okay, so yeah, definitely, I'm definitely gonna try playing with these little motors. That's pretty wild. Okay. Well, it looks like I'm 3D printing a design later. Because I'd have to face here, but I'd have to tuck the wires underneath here. So basically, I may have to make a little shaft. I'd put it in the little shaft and then would have to vent out and to cover underneath. I do have 2 of these, so I'll try it out, see how it is. But I think 1 unit of these costs like 10 bucks. I'll see if I could get away with 1. Let me see how much. Let me see how much it costs first. Thanks for hanging out while I do stupid stuff. AliExpress. How much did I pay? $12. So $12 for 1 of these. I'm just gonna hook it up. Hook it up to the cooling fan. I wonder if I could just do that right now. There's probably some number I'm missing I'm not thinking about. I'll have to ask people about it. Probably because these fans are $10, $12 bucks, where the ones that they're using now are probably like $1 each. Where they're getting charged like $5 or 10 bucks for the same exact brushless fan. I know I have a connector of it somewhere. There's bound to be a fan somewhere in here. Cool. Oh, I don't want. Looking through my pile of stuff. See if I got a fan. That's for 3D printer. I have a broken one of these. Where are they? Oh wait, it's over here. Oh. There we go. This one's broken. Oops, let me plug that camera back in. All right. We're gonna try some things, okay? Just for today. Damn it. Let me make that bigger. All right, let me go get my Wagos. Or something similar to a Wago. Oh, this should work. Oh, never mind. It's Wago, Wago, Wago. Pardon me, I'm just gonna look for a Waco. All right, these are kind of big, but they'll do.